So, good afternoon, everyone. Within a few minutes, we will start today's session. Yes, yes. Do you have any queries? Hello. So, hello, Yash. Do you have any queries? So, you can ask or raise your concern through the chat box, or you can use your mic also. Okay. So, we are starting this today's live session. So, before today's session, we have completed 4 sessions, and the last 2 sessions is regarding this fluid dynamics and fluid static portion. So we have solved various numerical regarding this topic. So let me introduce myself. I am Niloy from IIT Bhubaneswar, a PhD scholar, and this course of fluid mechanics is under the course instructor Professor Subhashish Datta. So I'll first elaborate a little bit about this course detail and why this course is important. So see in our everyday life what we are observing and each and every phenomena like the water flowing through a river or wind tunnel or anything you find is based on this concept of fluid mechanics. So if you need to solve a real life problem, then this concept of fluid mechanics is quite important. So that's why we will study this course. So it's an interdisciplinary course for this civil, mechanical, chemical, and also for the others. So in the last class, what we have discussed some numerical regarding this conservation of momentum and how we can implement this in real life problem. And also the most significant is this Bernoulli's equation. So this Bernoulli's equation is quite important for this fluid dynamic problem. So that thing we have also discussed. So in these classes also we'll recap few of the previous topic and some advanced numerical problem we will solve. So after this there are some numerical problem. Through this numerical problem we will go depth into this concept what has been discussed in the class. So I hope that all of you have gone through this lecture that has been uploaded in the NPTEL by Professor Subhashish. So please, if anyone hasn't followed this thing till now, so please go through these courses, which will be quite beneficial for you. And if someone is quite interested in giving this NPTEL course exam, so please follow this session also, live session, and similar types of numerical you can also find in this exam. So my plan is to in the next upcoming slide I will show you a question, and first I will give you a few minutes time to solve this question, and after that I will explain about this question from this underlying concept. So that is why we will go into this class. So this is our first question. In this first question what is told, say it has been mentioned that there is a man who is 1.7 meter tall. So he is standing vertically in the water and is completely submerged in a pool. So he is in the pool and is submerged. So you are asked to find the pressure difference between the head and the toe of this man. So that is the thing. So it's basically this simple concept of pressure. So pressure difference between 2 point, you know this thing. That is means the hydraulic pressure. So this is based on this concept. So please try to solve. I am giving you 1 minute time. So Yash and Shivam, you also try. And once you solve this answer, please respond through this chat box, or you can use your mic also. So please try. Mm, Okay. So Shivam has answered option C. So yes, if you wish, you can try, or will I solve it for you? Okay. Then I am solving this for you. So please have a look. So how we will solve this question? So first you need to you need to see what is given in this question. So first in this question the height of the man is given. So that means h is given 1.70 meter, right? So and also another thing that is and what has been asked to find the pressure difference. That means del P you need to find out. Okay. So see, I have explained a concept in the earlier classes that say this is an water level. So if this is the top point 1, so say the pressure at this point is P1 and this is another point say 2. So pressure at this point be P2 and the distance between these 2 points say H. So what I have said that as you go downward the pressure will increase. So I can write P2 means P1 plus rho G H, or I can write P2 minus P1 is equal to rho G H. Okay, that means this pressure difference is the product of rho G and H. So see here H is the man. So that means consider this is the man. So I am using another color. So this is the height of the man. So basically you need to find del P here. So the del P here means what is the liquid? The liquid given here is water. So we know the density of water means 1000, right, kg per meter cube, and G also we know this is 9.81 and H is already given. So I can write in place of rho Gh I can put this value 1.7. So the value that we will get is around 16677 Pascal, right? So but the in the answer it is in kilopascal. So that means we should divide it into divided by 1000. So that means 16.677 Pascal. That's why the correct answer is option see. Okay, that is how you will solve this problem. So this is the concept that you need to understand and you have to apply in such types of question. Okay. Yes, yes, we have also answered it correctly. 16.67, good. Both of you has answered it correctly. So I am moving to this next question. So this next question is a fundamental question and it is quite important for even in the interview perspective. So if you are sitting for in campus, off campus or on campus placement, so such types of question are often asked. So in this question, say that which of the following assumption is incorrect in the derivation of this Bernoulli equation. So these are the four options. So always remember this. You should remember this assumption in this Bernoulli equation. Okay. So you try to answer because I think that I have also explained about this thing in the last class. So let's see how many of you are able to answer. So I'm giving you another minute time. So Yash has answered the flow is rotational. And what about Shivam? Shivam is also the same opinion. Yes. So what are the main assumptions? So remember this assumption in this Bernoulli equation. So this assumption, there are many assumptions. So mainly six assumptions we need to know. The first is that it should be a steady flow, right? Next is the ideal fluid. Third is it should be in viscous fluid. That means there should not be viscosity in this fluid. The fourth is it should be irrotational. Fifth is the flow should be always along the streamline. The streamline. Okay. And last is the fluid should be incompressible. This is quite important. So many people confuse among this compressible and incompressible. So incompressible means this density will not change and compressible means this density can be changed. Okay. So see in the first option, so from this it is clear that this first option is not correct. So this is the answer because this assumption is not the correct assumption for this Bernoulli equation. So basically if someone is saying the flow is rotational, and so that doesn't implies that this concept hold goods, right? So always you have to remember that this main fundamental is that it should be non-viscous, it should be steady, it should be irrotational, it should be ideal and incompressible. Rest two are not that much important, but these four are the fundamental. Okay. So I am moving to this next one, next question. See, it's another fundamental question. So it is about either it is either the statement is true or false. You need to check. So if asked the question is the water pressure in the main pipe of a city at a particular location is given as 270 kilopascal gauge. So this is the pressure reading at any particular location. So you are asked to determine this if this main can serve water to this neighborhood that are 28 meter above this location. So you need to check whether if a place that is 28 meter above the main pipeline, whether this region will get water or not. So that thing you need to check. So this is similar to the first question. So please you the concept and try to solve. Okay. So I am giving you a 1 minute time. So just check whether you are getting this pressure or not, or you are getting this height or not. Hmm. Okay, Shivam. So you are not able to solve. Okay, no need to. So no such issues. So I'll help you to understand this concept. So yes, can you try or should I solve this one? Okay, if you will try. I'm giving 1 more minute. So for Shivam, I'm giving you a hint. So see, a pipeline is somewhere in this ground. Say this is the pipeline. So if a house is up at this distance, so that means this house, say consider this house is at the atmospheric condition and this pipe is here. So you can find the pressure difference, right? Because height is 20, because the 28 meter height is given, or adversely you can find from this pressure difference you can find the height and check whether this height is more than this one or not. So then you will be able to solve this one. Okay, just I'm showing you an hint. Say this is similar to the question that problem I have given. So like water, say this is water, right? As I have said. So if this is a point P1 and this is a point P2 and this is height h. So what I said that P2 this equal to P1 plus rho GH. So see, if I consider P1 equal to 0 means that means gauge pressure. So then I can write P2 equal to rho GH. Yes. So that is a gauge pressure. That means this pressure at the surface of the liquid, I consider this pressure as 0. And that means the reference line. Okay. It's like say if your height, if your height is 5 feet and someone height is 5.1. So I can say assume your height be 0. So what is the height of the person who is having 5.1 inch, 5 feet 1 inch? That means his height is 1 inch. So that is basically represent the reference or the reference value. Okay. So similar is this concept. So this is the pipeline. Okay, and this is the house. So the location of this house is uh, say 28 meter above this house, and okay. So the pressure is given. What is the pressure? The pressure at this pipe is given as 270 kilopascal gauge pressure. That means the reference pressure is considered as 0. So see, I don't know which is the reference line. Say this is the reference line. I consider this is the reference line. So this is H. So I can write P equal to rho GH. So P is given as 270 into 10 to the power 3. Rho is 1000 into 10 or 9.8 you take, or H. So this two will cancel out and this will cancel out. So that means H I get as 27. That means this reference line is at a 27 meter. That means up to this pressure the neighbor can get water, and after that it will not get pressure and get water, right? Because this is the reference line. The, and up to this pressure this water can travel. After this there is no such pressure difference. So if there is no such pressure, then how will this water flow? That's why it's a the answer is no. Do you get this concept? So please let me know whether you understand this concept or not. Okay, good. So I am moving to this next question. So see, it's a it's a tricky question, you can say. So what is given, the difference in the mercury level of a Peter static tube connected to a submarine is 25 centimeter. So assume that this coefficient of velocity as this one. What is the speed of the submarine if the specific gravity of the sea water is 1.019? Okay. So hmm. So I am giving you 1 minute time. So check whether this concept you are familiar with or not, or let me know about this one. So check, please check. So Shivam said that you haven't any idea about this concept, right? Okay. Okay, it's a tricky concept, so let me solve this one for you. Yes, so I am solving this one for you. So you try. If you wish, you can also try and check whether this answer matches with my answer. So first, the concept is that it's a pitot static tube. So how this pitot tube exactly works? So it works based on this pressure difference between a stagnation point and a static point. So what is the difference between the stagnation and static point? Static point means a point where which is at there is no such velocity at this point. Whereas the stagnation means the velocity, whereas stagnation means the point where there is a velocity. So that is basically the difference. So if you measure the pressure at a static point and if you measure the pressure at the stagnation point, and if you find out the difference among these 2 points, then you will get the difference in this pressure, and that has been reflected in this Mercalli column. Okay, so that is the concept that we are using in this pitot tube. So from this pitot tube concept I can write change in pressure should be the difference between stagnation and static. Okay, so this stagnation means a pitot tube there is mercury, right? So this stagnation pressure is corresponding to this mercury one, rho of mercury, right, into G. Say it rises up to X height minus of C. Sorry, this is static minus stagnation. C into Gx, right? That means C. If I so that thing is clear. So I can write this means rho Hg minus rho C into Gx. So you can find the difference. So now I know that if I need to find out this is equivalent to this equivalent dynamic head. So which is H? So I can find out equivalent dynamic head. That means I am converting this pressure difference as a dynamic head. So I know that if I represent this pressure as this pressure, say I am taking this one as a dynamic pressure. So I can write this one as rho C into G into H. That means this pressure is X is the reading. What is X? This X is the reading of this pitot tube. Okay, and this H is corresponding to the original value. If certain pressure difference we need to get in a C, right? So that is the concept. So I can find from here I can find H into rho Hg minus this C by rho C into X. So that is the concept. Okay, so we get this value, so I can find what is the, for this mercury I know this rho value, that is 13600. Then for the C, the specific gravity is given, this into 1000 will give me the density, that means 1.0, sorry, 1019, and below will be okay into x. What is the x? X is given as 25, that means 0.25 because it is in centimeter. So if you calculate, you will get this answer as 0.308 meter. Up to this it is clear. Please let me know. So someone has responded. Mhm. Okay, so I think there is a little bit confusion among you. So see, I am just drawing this pitot tube for your better understanding. So basically, so see, water is flowing in this way. This blue line represent water. This is the flow, and this one represent this pitot tube. Okay, so see, as this water flowing, and also up to this is water. See here also water, some amount of water will flow. See, up to this amount of water is flowing, and in this pitot tube there is mercury, right? This one is mercury. So if I check this thing, so this difference is the h. Okay, or not, this difference is the x. So that is the thing that I am talking about. This is the pressure difference. So why this pressure difference is there? Because see, there is water, this blue line, this portion is for water, right? So corresponding these two point, we can find out this pressure difference. So that's how we have got this formula. Okay, now is it clear? Say yes or no. Okay, so now I am solving the rest thing. So what I have got, this age means 3.08 meter. Okay, so this thing I have got. So now I can find velocity. So v, this is 2 g h root over. So this is the actual. So this is the theoretical value. That means in theory what the value we are getting. So you can put this value 0.08, right? So you will get a value. This value is 7.78 around, right? But in this question the coefficient of viscosity is there. That means this tube there is some error is there. So that's why the formula is there. Experimental this equal to c. C is the coefficient of viscosity into velocity, exact theoretical value. That's why we have to multiply this with 7.78 and we will get this answer as around this one. Okay, so the correct option is option C. See, it's a little bit complicated question, but please try to understand this thing. So you understand how this H has come. So have a look. So the Shivam and yes, check. If any confusion, please let me know, or I will move to this next one. See, okay. So I am moving to this next one. Can I? Okay, I am moving to this next one. So the thing is that next question. Shivam said that. So Shivam has some doubt. Okay. Okay. Let me clarify this thing. So see, Shivam, just this point, say this point is 1 and this point is 2. Okay. So I can write from this point that P2 P1 plus rho gx, right? Okay. So that is how this concept of h here comes here. So also what is given, the height we do not know. So I can correspondingly I can find the h. This can be written as this is P2. So this can be written as rho mercury into G into H. So correspondingly we can find out this value of H. And after finding out this H, I have to calculate this theoretical value which is 2gs, you know, root 2gs, and I can find out this. Okay. So but here there is a coefficient of velocity is given. That means there is some losses. So that's why this coefficient is given. So we have to multiply this with this theoretical value. Then we will get this exact value. That's why we have multiplied. So now you got this. Okay, so I'm moving to this next one. So this is another question. This is another interesting question. So in this question, what is given? A 150-meter diameter of jet of water is discharged from a nozzle into the air at a velocity of 36 meters per second. So what is the total head value with respect to the datum at the ground level? So what is given? Velocity is given, diameter is given, and this datum value is given. So you need to find out the total head. So where this concept of total head comes from? You know, this concept of total head comes from this Bernoulli's equation. So you can easily solve this one, right? So please try to solve this one. I am giving just 1 minute because it's a simple question. So this pressure, total pressure. So what is the total pressure? This total pressure means this pressure head plus velocity head, or this kinetic head plus datum head. So if you sum up these three head, you will get this total head. So first check about this pressure head, and next velocity is also given. You can find out this velocity head, and also this datum value is given, height is given. So Shivam has responded option B, and Yash A. So let us see which one is correct. So it's good that you are responding. So in this question, what is given? First we write down what is given. So given diameter as 150 mm. So always remember, convert each and every terms in terms of SI unit. So that means it should be to 1.5 meter, sorry, 0.15 meter. Also the velocity is given, that is 36 meter per second, and what is given, z is given, that means datum line from this ground level is 2.5 meter. So and another important thing, that this is discharged into the air. So if it is given in the air, that means this pressure, atmospheric pressure, I consider this atmospheric pressure as 0. That means this is gauge pressure. Okay. So I am considering this gauge pressure because nothing is given. So I have to consider this gauge pressure. So total head I can calculate. I know this formula. That is total head means this pressure head. This pressure head means P by rho g. Velocity head is v square by 2g plus z. So Sp is 0. So that means no need to calculate this pressure head. So we need to just calculate this kinetic head and this datum head. So this kinetic or the velocity head you can calculate 36 square by 2 into 9.81 plus z is 2.5. Just calculate and check what value is coming. So I'm just calculating this thing. 36 square to, So it is coming around, this value is coming around 68.555. So I think Yash has made mistake that you haven't add this value of z. That means the datum add. That's why your answer is coming A. But as it is given that with respect to this datum at the ground level, that is 2.5 is already given. So you haven't I think you haven't calculated this one. So the correct option should be option B. You understand the mistake? Yes. Okay. So we are moving to this next question. So it's a short question. It's based on this. At a diverging section of a venturimeter, the pressure is dash and this velocity is what? So please try to answer. So this is a simple concept on this Bernoulli's equation. So see this venturimeter, or if you talk about this pitot tube, each and every device works on this Bernoulli's principle. So if you understand this Bernoulli's principle, you will be able to answer this one. So please try to answer this one. So I'm giving you 1 minute time. So Shivam has answered option C. What about Yash? Okay, I am answering this one. See, it's based on this concept. So here, what is given? This a diverging section of a venturimeter. That means it's a, say this is a venturimeter, right? Diverging section. That means the area increases. If this one is A1, this one is A2. So as it is a diverging section, so A2 should be greater than A1, right? So they talk about this pressure and velocity. So now if I apply this continuity equation, what exactly it is? At this section, one section and this two section, if I apply this continuity equation, I will get rho A1 V1, this is equal to rho A2 V2, right? So same density, so that means it can be cancelled out. So I can write V2 by V1, this is A1 by A2. Okay, so as A2 is greater than A1, that means this term is less than 1. Okay, so that means V2 should be V1 is greater than V2. That means if the area increases, this velocity will decrease. So that's why velocity decrease. Okay. So we got the details about this velocity. Now for this pressure. So we know from this Bernoulli's equation is that total pressure head, that means P by rho g, b square by 2g plus that this should be constant at 2 point, at any 2 point. That means here h1 should into h2. So consider at any point that z should be equal because it's with respect to this ground. So if that is z2, that is z1. So you see that both of these are equal. So I am not considering this effect. Okay. So if I consider this effect, I am changing this color. So I can write P1 by rho g plus V1 square by 2g plus V2 square by 2g. So I can easily write P2 by rho g. This is equal to this term minus this one, right? Okay. So another thing you can also check, see in the initial point here this velocity is more. If this velocity is more, and then this pressure should be less, right? As this value will, left hand side and right hand side will not be equal. That means we can also say from this Bernoulli's equation that whatever be this kinetic energy, if this in another section, if this velocity decreases, that means the kinetic energy decreases. That means where this energy goes, this energy is converted into this pressure energy. So the pressure will increase. So remember, if the velocity decreases, that means this kinetic energy decreases. So at what expense? So it does so by increasing this pressure. That means by it absorbs this pressure. So this pressure energy increases. So that means it increases or recover. So this correct option is option C. Okay. So I am moving to this next one. So in this question, what is given? A liquid having specific gravity of a liquid is given. Also its value of Q is given, and what is given from point 1 to 2, which is 1 meter above this point 1. The diameter is also given of these two sections. So pressure at one section is given. You need to find out this pressure at another section. So just remember, if such types of question is given where you need to find out this pressure, so always remember this is a problem of this Bernoulli's equation. And if there is any terms regarding this diameter and velocity, then remember that this continuity equation can also need to be applied. So please try to solve this one. It's based on this concept of continuity and Bernoulli's equation. So I am giving you a 2-minute time. So in the previous class I have also solved such types of question. So please have a look to this question and please try to solve. So I am giving you another hint that say here the value of q is given, right? Also diameter is given. So you know q means q is equal to a into v. Also from this continuity equation you know that at two section a1 v1 this is equal to a2 v2. That means which is exactly this flow rate, that is q. So from this formula you can find out this velocity term, right? Now you can apply this Bernoulli's equation. In this Bernoulli's equation you got this v and also this pressure is given. Okay, at point 1 this pressure is given and there is no such details about this z, that means datum line, so you can consider them equal and rest is quite easy for you. So please try to solve. Another 1 minute I am giving you. Okay, so it's very good that you have tried. So no need to worry. So I will solve this one for all of you. See, check and let me know if you are not able to understand any concept. Then I will again explain this thing. Okay. So first in this question, so what is given? So specific density is given 1.3. That means if the specific density is given, so I can find the exact density. That means 1.3 times into density of water, right? That means 1300. This should be the density of the liquid first. Next is this 800 liter per second is given. That means Q is given as 800 liter per second. So I have to convert this into meter. Always remember each and every term should be in SI unit. So what I need to do, this is corresponds to, that means you need to divide it by 1000, then you will convert it into meter cube. So Q is given and from point 1 to 2, which is 1 meter above point 1. Okay, formula in Z is not equal, it is given this point 1 to 2, which is 1. So that means here it is given that the Z2 is 1 mm, 1 meter, right? Because if it's a point, it is another point. Okay, say this is a pipe, the pipe is like that way here. Say this pipe is at an angle, so this is 1 point and this is 2 point, right? So given 1 and 2 is at a distance of 1 meter. That means I can write, if this is Z1, Z1 should be 0. If I consider this Z1 as the reference line and Z2 is 1 meter, so that's why I write Z2 is 1. And also what is given, D1 0.2 meter and D2 0.1 meter, right? Up to this it is clear? Up to this it is clear? Okay. So now see, I know this continuity, since it's a pipe flow, so I know that this continue, I can apply this continuity equation. What exactly this continuity equation is? That means in this section, since it's the same fluid is flowing, so already density will be cancelled out. I can write A1 V1 equal to A2 V2. That is the formula. Okay. So what exactly A1 V1 means? That means it's the flow rate, right? So from here I can find out A1 this equal V1 Q by A1, right? So Q, what is the Q? Q is 0.8. Area, since it's a circular section, area means 4 pi by 4. What is the area? The area of this section is 0.2. So it's a bigger section, right? So if you, then you can calculate. So it's a 0.6, not 0.2. 0.6 and 0.3. So it's a 0.6. So you will get this value, right? That is this one. Similarly, you can find out V2. This will be Q by A2. So you just calculate. So that means in here A2 should be 0.3, in place of 0.6 it should be 0.3 square. That means it should be 4 times more than this one. So it will be 11.32 meter per second. Up to this it is clear? Please let me know. So I got this V1, V2 and each and everything. Please let me know. Okay. So now what is, I need to find out this pressure. So for this pressure I need to apply this. So I am erasing this thing, right? So now I am applying this Bernoulli's equation. Say from this, again I am drawing this thing. This is 1 meter, I already draw. This is 0.6, this is 0.3 meter diameter, I know. So velocity, the velocity I got 2.83 meter per second. Velocity I got 11.32 meter per second. See, as the diameter reduces, the velocity increases. We have studied in the previous question. That is the thing. Okay. So Bernoulli's equation I can write. So what is the pressure at region 1? So that means I can write P1 by rho g. plus V1 square by 2G plus Z1. This one equal to, in this section, for this section it will be rho G plus V2 square by 2G plus Z2. Okay. Also another thing is a pressure at 1 is given. What is the pressure at 1? This is 10 bar. So I have to convert it into Pascal. So 10 bar means 10 to the power 5, 10 into 10 to the power 5 Pascal. Okay. Or this can be also written as 1000 kilopascal. No need to write about kilopascal, just for your understanding I write it as kilopascal. So here, if Z1 equal to 0, then what is Z2? Z2 is 1. So you can put in place of Z2 as 1 and Z1 as 0. Pressure has 10 to the power 6 Pascal. Velocity 1 is 2.83 and velocity 2 you know 11.32, and rho also you know from the previous slide. What we got, rho is 1300. Okay, so you just put, you will get P2. Putting all this value you can calculate P2 and you will get this value as 9092 kilopascal. Kilopascal means into 10 to the power 3 Pascal. So if you need to convert it into bar, you need to divide it by 10 to the power 5, right? So that means 9.02092 bar. So see if it is clear to all of you. Please let me know. Okay. Okay, so can I move to the next one? Okay, I'm moving to the next question. So it's in the question 7 is quite important, and similar types of question you will definitely find in the exam. So I'm moving to the next one. So it's our real life problem. So what is given? So you see this picture where a person is checking his BP, right? So here in this device there is mercury. This mercury reading helps to detect what is the pressure, right? So in this question, what is given? 120 mm Hg gauge pressure is given, right? And density of blood is given. What you are asked to find? You are asked to find what is, how high the blood pressure will rise in the tube. So that means how much? So it's mean, say this device is showing the pressure reading. So you are asked, if the blood you put in a test tube, then how much pressure it will, how much it will rise, correspond to this pressure of this mercury. So basically I'm just giving you a hint. That means here whatever be the blood pressure, that should be equal to this mercury pressure, right? That's why we got to know our exact blood pressure. So you just use this formula. Pressure is rho gh. So if you use this formula, you can easily find out this thing. So please try, everyone. So blood pressure should be equal to mercury pressure. So for this mercury, H is given, that is 120 mm. So you can find this pressure of this mercury, right? Similarly, you can find out this blood pressure because the density of the blood is given. You need to find H of blood. What you need to find? You need to find H of blood. I am giving you 1 minute time. So Shivam has answered option D. Let's see about others. So I'm giving 1 more minute. Okay, I am solving this one. So see, as this pressure measuring device is used to measure our body pressure, so blood pressure. So this pressure of the blood should be equal to this pressure shown in this mercury reading. So that's why in place of blood pressure I can write rho of blood into G of H of blood, rho of mercury into G into H of mercury. Any confusion up to this? Rho of blood, that means here it is given 1020, and G, see, the G will cancel out from both sides, and H blood I need to find. For this mercury I know it should be 1300, and H of mercury what is given in this question, that is 120 mm, means 0.12, right? So you will get H of blood. So if you calculate H of blood, what you will get? You will get 1.6 meter as a solution. So please check if you understand this concept or not, and let me know. Okay, anyway, I'm moving to this next one. So in this question, what is given? A metal plate, dimension of a metal plate is given and its weight is also given. Say that it is placed midway in a vessel. So this gap is filled with an oil. So it has been filled in an oil. Whose specific gravity is given and dynamic viscosity is also given. So you are asked to find the velocity at which the central plate will move. So it's another interesting question. So I'm giving you 2 minute time to check how much you understand this concept or not. So it's based on the concept of the body force by buoyancy force, and also since here viscosity is given, so the concept of viscosity will definitely come. So please try. Okay, I think that you. Okay, I'm solving this one. So in the meantime, you can also try to solve this one from your side. So this figure is quite given. So from this figure, it is quite obvious that this metal plate, which is shown black in color, so its weight is given as 19 Newton, and it is placed in the 24 gap between two vertical plates, right? That means its weight is given. This W is given as 90. Okay, that is given here. And also its 25 distance is given and 6. So what is the distance between this end to this end? This is 9 mm. Okay. So after this it is clear. Since it is dipped into the water, so there should be buoyancy force. So I can write buoyancy. What should be? It should be the why this buoyancy is there? It should be because of the displacement of this fluid because of this uh, plate particle. So I can write what is the fluid? The fluid is what? G is 9.81. Okay, and you need to find out the volume of the plate. Okay, up to this it is clear. Because oil it is given 0.85, so I convert it into density, that is A2 into 1000, and this is G value, and this is the volume. What is the volume here? 1.25 into 1.25 into 6, 0.006. So you will get an answer of the year, that is 781.17 Newton, right? This is the buoyancy and this is the weight force. So buoyancy force, so I can write buoyancy as I know this buoyancy, so F net I can find out, which is equal to W minus FB. So which is 90 minus 781. So that is 11.83 Newton. Okay. So that is the F net we get. So total force. Again now see. So for this viscosity, so from this Newton law of viscosity we know tau equal to mu V by H, right? So now since the fluid is moving, so what I can write? I can write this, whatever should be the F net, there should be equal to F of viscous. Okay. Therefore F viscous equal to, okay, F net equal to F viscous. So you can find out F viscous equal to F net. So sorry, this is the formula. You can use F viscous, that means say tau into A. Why it should be tau into A? Tau is the shear stress into area, you will get this as the force, and also since the plate has two ends, so there should be two terms, right? So accordingly you can find out this value. So I can write from this equation, what I can write? I can write K 2 into mu V by H A. Okay, this is the thing we have got. So now you just put this thing value and you will get, see, what is F net you have calculated earlier, that is 11.83. So no need to calculate F net. So this formula you need to just find out, nothing. So after finding out, so you will get, see this value, and now what you need to check, I got, so I'm using another color. Say F net I got as 11.83, right? So next H is the distance, this distance, then H is 9 mm, right? So you got H, you got F net, mu is also given, mu is 3, area is also given, 1.25. Okay, So that is how this problem will be solved. So after solving you will get V is equal to 0.01. So is this concept clear to everyone? Please let me know. So what we initially do, we find out this buoyancy force, and after that we find out this net force, which is this weight force minus buoyancy force. And now we find out this viscous force. Why there should be 2 tau this viscous force? Because this plate is exposed to 2n and both end it experience this viscous force. So that's why it should be 2n. And we putting the earlier values of F net, we are processing this. Okay. So the final answer should be 0.01. See, sometimes it happens that in the question it will be asked, they ignore this effect of buoyancy force. So then there is no need to calculate this buoyancy force. So then net force is equal to this weight. So no need to subtract this buoyancy force at that case. In some of the question in your books, there are such types of problem where it is mentioned that this ignore this buoyancy force effect. Okay. Up to this, I think it is okay. I am moving to this next one. So plus, first read this question properly. So in this question, what is given? It's underground water is pumped to a 70% efficient 5 kilowatt submerged group to a pool whose sea surface is 30 meter above the ground. The diameter of the smooth pipe is 7 centimeter on the intake side and 5 centimeter on the discharge side. Determine. So various things need to be calculated. The first is that maximum flow rate of water we need to calculate. Next is the pressure difference across this pump. Also we need to calculate. So please try. I am giving you 3 minutes to solve this one. It's a tricky one. So see this question, also in this question, as you are asked to find this flow rate, so continuity equation is required. Right, pressure difference is asked, so also Bernoulli's equation is required. So now it's up to you how you utilize this question to solve. The hints are also given. So have a look into this question, what is given. Okay, so I'm giving you another hint. So in this question, what is given? First, I'm writing down this thing. So only submerged pool is 30 meter is given. Okay. The diameter of the smooth pipe is also given. So see, in this question first, if I write diameter is given. So one diameter is 0.07 meter intake diameter, and outlet, that means the discharge one is 0.05 meter. So diameter is given, you can calculate area, right? So power is given, right? Because pump is given 70% efficient at a submerged at a kilowatt, that is a power. Okay, so we know that power means pressure into volumetric flow rate, right? So in place of what is the power? Power is 70% of it of 5 kilowatt. That means I can write 70% of 5000 is the power, and what about this other value, right? So say it said this, uh, if you observe, you know this pressure, right? So accordingly you can find out this volumetric flow rate formula, you can find out this other thing. So now you just try to calculate this one. Okay, so please try. So I'm just giving you hint, so please try. So try. So either you understand how to calculate this pressure or not. Okay, let me solve this one. So that means rho gh, right? So you can calculate rho gh. Rho gh into q. So that means 0.7 into 5000. This equal to rho of water is 1000 into g. Assume it as g, and this is 30 meter. So and q I need to calculate. So if you put this thing, you will get this q. This q we will get as 0.0119 meter cube per second. That is what we have got. So please check. So now q is given, diameter is given. You can find out velocity using this continuity equation. So please calculate. Someone has responded. So Shivam said this option B is the correct answer. So let me check. So I'm erasing this thing. Okay. So what I have got? I have got this Q means 0.0119, right? So from this continuity equation, what I can write? A1 B1 equal to A2 B2 equal to Q. So B1 means Q by A, right? Q value we know, area also we can find out using this diameter. So in place of Q I can write 0.119. From this area onward I can write this one is 0.07 square. Accordingly I get 3.09 meter per second, right? Similarly you can find out B2 which is Q by A2. So just calculate and tell what is the value. So the value is coming out to be 6.06 meter per second. Okay, so both the velocity we have got. Now we can calculate this. See, in the first question, this value of the maximum flow rate that we have got as 0.001. So from this, what we have got that option C and option B cannot be the correct answer. So only remaining is option A and B. Now we have to check for the pressure difference across this pump. That means P1 minus P2. There is pressure difference across this 2N. So now for this I have to use this Bernoulli's equation, right? So just remember this velocity value. So from this Bernoulli's equation I can write P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z1. Okay, so that is the thing here. So what has been given in this question? So any details about this there? Nothing is given. That means we have to consider both these things should be equal, right? So I consider this Z1 equal to Z2, and I also got this V1 is 3 point what is it, 3.09 meter per second, and V2 I have got as 6.06 meter per second, right? So 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 these two things will be cancelled out, so I can write P1 minus P2 this equal to V2 square minus V1 square 1 by 2g into rho g. Hmm. So this g will be cancelled out, so what I will get this value. Accordingly you can calculate and you will get this value of the pressure difference, which is around 280.71 kilopascal. So this correct option is option B. So I think you understand this concept. So please let me know if you have understand this one or not. Okay, so you have understand this concept. So I'm moving to this next one, right? Next question. So this is a question. In this question, what is told? A jet of oil with relative velocity issue from this nozzle of a nozzle of 15 centimeter diameter with the velocity of 12 meter per second. A smooth cone with vertex angle 90 deflects the jet. The jet is horizontal and vertex of the cone toward the jet. So you are asked to calculate the force required to hold the cone in this position. So our objective is to hold the cone in position. There should not be any movement here. So how will you solve this one? Already the figure is given. So see, velocity is given, diameter is given, and figure is given. So you have two options. Either you equal, since pressure, no details about pressure is given, so no need to use this energy equation. So you have two options, either energy equation or either continuity equation and momentum equation. Energy equation is not required here, right? So use these two equation, continuity equation and momentum equation, to solve this one. So again I am giving you 2 minutes time. So see, I am just giving you this hint that here this nozzle is flowing here from here. So there is a cone shape arrangement. So the objective is that the cone should be placed in this path in such a way that this jet shouldn't move this cone. Okay. So because of this cone, the velocity is departed in 90-degree angle. So our objective is to keep this cone fixed in this position. So what is the force that we need to give to this cone in a order to fulfill this thing? So that is the concept here. Okay. Okay, I am solving this thing for you. Check, please check. So see, if the flow is in this direction, so flow velocity is given, diameter is given. So we know, first I am applying this uh, continuity equation. Why I am applying this continuity equation? Because I need to know about this mass flow rate, right? So what exactly is this mass flow rate? So I know this mass flow rate is means rho into AV. This is the mass flow rate. So density I know, whether I know this density or not. Yes, in this question, any details about this is given or not? Nothing is given. but an oil is given, so it should be given. Generally, the specific heat of, sorry, the specific density of Pa is, of oil, specific density of oil is 0.8. So by mistakenly it is not provided. So I can write the density should be this one. Okay, and area. What should be the area here? Area should be pi by 4 into d square. What is d? 0.15 square, right? This is area. Okay, and what about this velocity? Do you have any idea about this velocity? No. So this thing will be like this one here. No, no, velocity is given. So velocity is 12. Okay, so we can calculate this value of the mass flow rate, which is 800 into this one. So please tell what is the value coming out. This is 800 into 3.14 into 0.15 square, right, into 3. So that is the value which is coming here. So I can write in place of this one, I can write it is 169.56. So that is the mass flow rate. Okay, so that is kg per second, right? So I got this mass flow rate. So up to this it is okay. So I am erasing this thing. Can I? I think so. So I got this mass flow rate. So now I have to apply this momentum equation because only velocity is given, no details about this pressure is given. So as it is in this direction, x direction, so applying this momentum equation in x direction, what I will get, I know that this summation of force in this x direction should be equal to this mass flow rate into whatever is going out or inlet, out minus bx in. Okay, so see, this is the value. So see, I am considering in the direction, in this direction. So what is the force acting in this direction? So only Rx is given, but it is in opposite direction. So that means in this, so I am taking this positive x-axis as the plus axis, whereas its opposite direction is represented as minus. That's why the total Rx should be minus Rx. Okay. The mass flow rate I know. What is the mass flow rate I have got? This is 169.56 into velocity outlet. Outlet means this one, but it should be in the x direction. So the I need to take this component. So this component is v cos 45, right? So I can write v cos 45 minus only v, because at the inlet it is in vertical direction, so no need to do so. So after that you can calculate, and accordingly you will get the value as 595. So that is 595 Newton is the correct answer. So option C is the correct answer. Okay. So this is some of the important question, and it is quite different from the previous classes. So please go through this question, and we will discuss now some theoretical and fundamental concept about this one. Okay, I think this concept is clear to you all. Now I am moving to the next one. Hmm. So this is also a similar fashion question. So where in this question, what is given? So Q is given. This Q is 2 meter cube per second is given. Diameter is given, right? D1 is given as 1 meter. Also the pressure is given. P1 is given as 40 kilopascal, and D2 is also given as 0.5 meter. So we are asked to find the pressure of the water after the tube narrows to a diameter. So basically these types of tube they are talking about. So no details about this jet or the datum line is given, so I can consider Z1 equal to Z2, right? This is section 1, this is section 2. So first I need to apply this continuity equation. So from this continuity equation I am using another color. A1 B1 equal to A2 B2 equal to Q. So accordingly I can find B1 equal to Q by A1. So that means here the Q is 2. A1 is pi by 4 into 1 square, which is 2.54 meter per second, right? Similarly, V2 you need to calculate, which is Q by A2. Similar fashion you can calculate this value, right? Which is 10.18 meter per second. So we got this value of V1, V2. Now I can apply this in this Bernoulli's equation. What is this Bernoulli's equation? So see this Bernoulli's equation, I write it in red pen. So I can write T1 by rho g plus V1 square by 2g, this plus Z1, is it? Plus Z2. As I have said, no details about this datum line is given, so we consider this in the same horizontal line. Okay. So this so already this P1 is given 40. The value of P1 is no. V1 I know. V2 also I know. So accordingly you can easily find out V2. So putting this all this value you can find P2. So calculate P2. So please calculate P2 and check what is the answer coming. So both of you just calculate and tell. So, So Shivam say option D. Yes. So the correct answer is option D, that is 36.2 kilopascal. So option D is the correct answer. So another two simple question for you, both of you. This is just a theory concept. So the question is, this Bernoulli's theorem is applicable for which types of flow? Either it is for translational flow or laminar flow or turbulent flow or both laminar and turbulent flow. That is the question. So at least try to answer both of you. So I think Shivam is confident about this answer. He has attempted it quickly. So Karthikeyan, you please try. Okay, no more response. Yes, the correct answer is option B. That is, it is applicable for both laminar and turbulent flow. So see, uh, if I talk about this Bernoulli's theorem, so exactly this Bernoulli's theorem, we know that this theorem is a combination of steady state and steady flow and also the inviscid flow, right? So it does not require, as a it's a inviscid flow, so it doesn't require any other. Also another point is then it should flow along a streamline, so it doesn't require the flow to be laminar or turbulent. So only the main condition is that it needs to be steady, inviscid, incompressible, and irrotational. That is the thing. So either it can be laminar, it can be turbulent. So it doesn't matter. It will not affect this Bernoulli's theorem unless and until all other assumptions remain constant. So that has been said regarding this Bernoulli's theorem. So similar is another question. So this in this question it is talked about this Bernoulli's theorem. Say that this theorem is derived from which theorem? So these three are there. The Stokes theorems, Newton's third law, Euler's theorem, and Gauss law. Which? So please try to answer. So already Shivam has answered option C. Yes, Shivam. So option C, yes. Option C is the Euler's theorem. It is correct because in the Euler's theorem, by applying this assumption, we will get this Bernoulli's equation. So it's quite essential to know this assumption, right? So up to this is for today's classes. So we will any confusion regarding this today's classes, please let me know, or we will end up this class is live session. Okay. So we are going to end up this. Okay. And thank you all. Also thank you Shivam. You have attempted so many questions correctly. That's good. and others also. So if you have any confusion, you can mail me. And also these videos will be uploaded in the YouTube. You can have a look if you have any confusion. Also the previous video has been uploaded in the YouTube. So this link will be shared with you through this NPTEL mail. So anyway, have a good day. Bye.